In March 2024, we celebrated International Women's Day and also celebrated the launch of the Emerging Tech Unpacked podcast. We held our first live event recording at Western Sydney University, and today's episode is a live taping from that recording. We spoke to incredible women in science, technology, engineering, and mathematics about their emerging tech topics, and we also delved into their interesting careers, how to get over imposter syndrome, advice on pushing back and saying no, how to career pivot, and being brave and saying yes to more opportunities. Welcome to Emerging Tech Unpacked, a podcast series about setting the record straight on emerging tech myths and profiling incredible women in STEM leadership. My name is Lucy Lin, and today we have a special live recording from two guests, and we continue our conversation with them. Our first speaker was Niina Matthews. Niina is a PhD candidate at the Gentile Lab School of Biomedical Engineering at the University of Technology, Sydney. Niina investigates 3D bioprint cardiac patches with a patient-specific design for localized treatment of heart failure. A 3D printing and bioprinting geek who loves 3D design, making eye-catching graphics, and communicating scientific ideas with a dash of humour blended in, Niina is a mum, an ally, and an internal advocate for creativity and diversity. And our second speaker was Dr. Louise Brown. Dr. Louise is the CEO and founder of Hydgene Renewables, a deep tech synthetic biology startup. Prior to her role at Hydgene, Louise held academic positions at universities and spent over 2 decades working on bioengineering complex protein systems. She played a key role in establishing synthetic biology in Australia with a focus on chemical manufacturing, and is passionate about contributing to the global transition towards net zero economies. Here is our panel titled Inspiring Inclusion: How to Empower More Women in Emerging Tech. Please enjoy.
Thank you so much, Niina and Louise. We're talking about deep technologies here. We're going to use no jargon because we're here to kind of make it very simple terms. We want to break down the barrier of emerging technologies. And at the same time, I really want to go through the incredible careers of these women, because they do have incredible careers, and talk about how they got to where they are. So first, we have panel, these two incredible women. Can you tell us a short story about your career to date and how you got in your current role? So maybe we'll start with you, Niina.
All right, so once upon a time, there was this little girl who was born in Finland. So this weather is really not doing me any favours.
She came in, it's just so hot.
So from high school, I went to TAFE, equivalent of TAFE in Finland, and I got a car mechanics license. But that wasn't enough, so I went to study an engineering degree as well in logistics engineering. Fast forward a bit, moved to Australia, thanks to my husband, did about more than 10-year career in supply chain and inventory management, and decided in the end that career was no longer satisfying my personal values and what I wanted to do. So when our youngest was born, I kind of had to consider, if I'm going to do the career change, this is the time to do it, because otherwise it's going to be difficult. So when my daughter was 1 year of age, my son just started primary school, Mummy went to big school. And it was actually at Western Sydney Uni. So I did my undergrad at Western Sydney in medical science, human anatomy and physiology, then did honours at Uni of New South Wales on the COVID year, yay. And then I'm now doing PhD at UTS. And I'm going to tell you a bit later how I got my PhD supervisor, because it's going to be a networking story.
Oh, I like that. Excellent.
And today I'm here with you.
There you go.
Thank you for coming.
Wow, supply chain management to bioengineering. What a transition. And you, Louise, what's your backstory?
Yeah, I think my story's a little bit more linear. I left school. I knew I loved science, grew up liking science. I watched the Curiosity show. I think that's probably revealing my age a bit too much. And I did a Bachelor of Medical Science at Sydney University. I then went on and did my PhD in biophysics, or in muscle protein structure. fell in love with the physics of it, actually. So did start off thinking I was going to be a geneticist, but in undergrad I started counting fruit flies, and I thought, no, there's got to be more to this than counting fruit flies. So yeah, got more involved in spectroscopy and physics. Finished my PhD a long, long time ago. This century, though, I should say.
Not that old, Louise.
Oh, it's creeping up, but no, I don't feel old. And then went and postdoced in America, in Florida, at the National High Magnetic Field Laboratories. Had the time of my life, made awesome friends to this day, still the most amazing people. Came back to University of New South Wales, did a postdoc fellowship there. Then got an academic position at Macquarie University in 2005. So that's probably putting a pin on timelines for you. And then worked through the academic ranks up until associate professor about 2 years ago. And then a whole lot of research has happened in my group. I very much always focused on looking at problems at the molecular level. We stumbled across something quite interesting working with our undergrad students, and you can tell that story soon. And that's now led into the startup company that I'm now one of 4 founders and the CEO of, called Hydgene Renewables.
Yeah, so academic to female founder, what a journey. So let's talk about the tech first. I know that, when we talked about the biographies, some of it was probably a little bit like, whoa, what is this science? So maybe we start with you, Niina. Can you let us know what is 3D bioprinting? I think it's a fascinating thing, but I don't think everybody knows what it is. Maybe let us know in a very easy term, what do you actually do? And explain what is 3D bioprinting.
Okay, so you may have heard of 3D printing. So this is where we use a machine that has material that is typically it's heated up, it's melted, it comes from a nozzle, and it makes a 3D shape. So there's a platform where the material comes to, makes one layer, goes up, another layer, goes up, another layer, and you end up with this 3D form. So that's 3D printing in a nutshell. 3D bioprinting is no different. Mind you, there are other 3D printing and bioprinting methodologies than just the extrusion. There are later and others, but you're gonna fall asleep if I start on that. 3D bioprinting is no different, except that we use materials that have a biological component to it. So for example, what I print with is a hydro gel. Hydro water, gel, you can imagine I'm basically playing with airplane jelly. So if you think of taking a bottle of dishwashing detergent, turn it upside down, squeeze, and the soap comes out. That's what I try to print with. Easy. No, but there are ways to do it. So then if we want to build therapies around it, the gel, the hydrogel, can be incorporated with cells, with pharmaceuticals, or with materials that can be conductive. And these are printed with very specific 3D printers that can control the environment so that whatever you're introducing into the biomaterial will actually stay alive. So there, bioprinting.
Okay, so that's the mechanics of it. And to continue on with it, I like to see 3D bioprinting as to be able to overcome our organ shortages one day, and also to overcome organ rejection. Can you give us a link to how 3D bioprinting could go from that to perhaps a new organ one day?
What an excellent question. And I would like to emphasize the one day bit.
Yeah, one day.
Okay, so I'll give you an example of my work. So we are developing a Band-Aid for fixing the broken heart. So hopefully one day this will be an alternative treatment that will replace heart transplants. So you may know heart transplant, open chest, the old heart comes out, a donor heart is put in. That's very complex, it's very costly, not accessible. 112 of those were done in 2022 in Australia. There are 30,000 people with heart failure in this country, and that's just Australia. What we're hoping to do is make a patch with the hydrogel, where we take the patient's own heart anatomy, that's where I do the shape of the patch, and then we take the patient's own stem cells, and culture them into cellular material that turn into cardiac spheroids, which contains cardiomyocytes, which is the muscular cell that makes the wall of the heart do this. And then we want to transplant it to the area that has been damaged in heart failure, specifically, without opening the whole chest, but through a keyhole. At least that's the idea. But that's one example.
Yeah, amazing. I was reading this last year. There was a woman who was born without an ear, right? Or there's like burn victims and they've been burnt completely. Is this the type of technology that you can now have the patients regrow themselves? Like, you know, they can grow at one stage, potentially an ear or skin? Or is there other misconceptions about this?
Yeah, there are people tend to draw the line from A to B quite quickly. But with skin, yes, I'm aware that there are 3D printed skin, which is, skin, if you didn't know, has actually 5 layers, not 2 or 3, 5, and they're very complex. Skin definitely has been grown in laboratory for burn victims, and skin is one of the applications for 3D bioprinting, which is probably one of the furthest. Same with bone and cartilage. Will we be growing spare parts in the lab? Not quite. No.
30 years maybe? 50 years?
I would like to give you the politician's answer and say, yes, we'll see in the future. But yes, just to give you an idea, human heart has 3 billion cardiomyocytes of those little cells that make your heart beat. Okay? The patches we're making with the cardiac spheroids, one spheroid has 30,000 cardiomyocytes. So we're still talking of that scale. So we're dealing with cells, bit of tissue, very small piece of tissue, whereas the whole organ is super complex.
Yeah, okay, great. And what about obviously there's a lot of opportunities and challenges, and what about the future of this technology, you'd say? It's very complex. You told me it was kind of like a tower of soup that you're doing. Where are we going? How far away is 3D bioprinting?
3D bioprinting an organ, as in a full functioning organ?
Potentially.
Potentially. Yeah. Depends on the organ. but I would say that what we are doing today is very, very promising. Yeah. And I think this is a technology that it's going to keep evolving, and it's going to be doing this really rapidly. But unfortunately, the technology we have with it and also the legislation we need to support it is not moving as fast.
Yeah.
So there are a lot of hurdles in terms of getting the right materials and getting the right kind of equipment for making these tissues that can hopefully one day build an organ. And then we need to deal with TGA and others who will hopefully one day give us a permit to actually test these in humans. But yeah, we're still dealing with cells and small tissues.
Okay, very cutting edge technology. I love it. Thank you so much, Niina. Louise, so you're an academic and now you're a female founder. Can you tell us a little bit more, like your specialty is green hydrogen. I did not know anything about green hydrogen, I have to admit, before I met you. Can you tell us a little bit more about green hydrogen, what it is, and how is it part of renewable energies?
Sure. Green hydrogen is a chemical, and it's the most abundant chemical on this planet, but we need to make it. And today, it's made from the fossil fuel industry. So there's this misconception out there that it's a clean fuel today, but it's not, because of the footprint of CO2 production when it's made is not good. I mean, we call it brown hydrogen today. So for every tonne of hydrogen we make, there's about 10 tonnes of CO2 that is made as well. So it's all coming from the fossil fuel industry. But it's a super important chemical today. There's quite a large industry. We make about 100 million tonnes globally each year. About 55% of that goes into making ammonia. So if you know your chemistry, you've got the Haber-Bosch process. Ammonia is important because it's used for synthetic fertilisers. Why do we need fertilisers? For the food we eat. So most of us are made from hydrogen that's come from the fossil fuel industry because of the food we've eaten. So we absolutely need this chemical today. So about 55% goes to ammonia production for fertiliser. We've got about 25% of the hydrogen that is made gets used back in the oil refining process. So the oil companies love making hydrogen because it helps with their production. So we're hoping that that application goes away. And then about 10% might be used for other chemicals, things like methanol. So hydrogen is such a key core element for making many other chemicals. So I think there's misconceptions out there that we've got this amazing green hydrogen economy. We're all about to fly around in planes fueled by green hydrogen. We're all about to have a green hydrogen car, or we'll have a choice between our electrical car or a green hydrogen car. That's a lot of hype out there. There's a lot of hot air. There's a lot of tail wagging the dog about what this hydrogen economy looks like. So the real challenge with this hydrogen economy is the decarbonisation of how we make hydrogen today. So we have to transition from hydrogen that's made from the fossil fuel industry to greener ways of making it. Can we make it without that carbon dioxide footprint? So when you leave tonight, just please think that this green hydrogen economy is coming and we need to transition, and we can't live without hydrogen. We absolutely need it. We can't electrify everything. We need green chemicals. We need it for methanol, ammonia, but there's lots of other chemicals that we're going to need it for. Things like sustainable aviation fuels. Qantas is setting very big targets, throwing lots of money at it. Some companies have quite clear mandates that we have to transition to cleaner fuels. That will happen. And so it is a chemical in itself. We can also couple it or put it through what we call a fuel cell and turn it into green electrons. But that's a very inefficient process. That's going to be very expensive electrons. If I have a solar panel or a wind farm, I'm better off just using those green electrons for what they are, electricity. So you might often hear about, or Twiggy Forrester talks about these big green projects happening over in the Pilbara in Western Australia. They talk about these large-scale renewables that are going to be needed to feed these electrolyzers. So electrolyzers is just splitting of water, and you need energy to do that. So we use the sun and wind to split water. We need to do that at scale to replace all that brown hydrogen we're making from the fossil fuel industry today. And the solution is, let's do this at massive scale. But if you start looking at some of these projects, they're huge. You've got 80 kilometres by 80 kilometres of just solar farms taking over the environment. So the vision is there, but this new economy, greener hydrogen economy from electrolysis using renewables is not quite there. So yes, that's going to give us green hydrogen, but not fast enough. So what we've done with our technology is there's other ways you can make hydrogen. And if you go and look at nature or biology in particular, and I love it that we're both biologists, really, yes.
Medical scientists.
And medical scientists. Yeah, we have lots in common, I think. Yeah.
And they're both born in April, I found out.
And April birthdays, correct. We're both Aries, we've discovered.
What's your mother?
We're twins separated from another mother. Yeah. So where was I at with my story? Oh, microbes. So we in my research group back at Macquarie University, I worked with another professor, Robert Willows, and we've always looked at organisms and what they can do in nature that we can learn from. So if you look at green algae is a single cell microbe molecule, and there are species out there that can make hydrogen. They can take sugar and convert it to hydrogen. And they do that when they're under oxidative stress. And I won't bore you with the chemistry of it, but they've got the DNA code for being able to make hydrogen from sugar. But they don't do it very well at an industrial scale. No one's going to be running an ammonia plant off green algae. They've tried that. But what we now have available to us is better tools for reading DNA and writing DNA. And we can do that on a computer. So we can study these other amazing microbes out in nature, look at how they do things very well, copy that DNA, put it into something we can better domesticate, and we use bacteria in our lab. So we've put the code from one organism into one that we can grow at scale. And then we've created a synthetic microbe that can now take sugars and make hydrogen gas and do it in a clean way. The sugars we take from biomass. So biomass is just plant-based material. Anything that has once been living has these sugars or carbohydrates. And there's a lot of biomass residues out there. It's not just what we grow on the farm. We get it from the forestry sector, industrial food scraps, paper pulp residues, even human sewage, because of the paper in there, has biomass. So we can turn any sort of biomass waste material now into green hydrogen using this synthetic organism that we've engineered.
So you both switched careers. You know, you were academic turned female founder, and then you were a supply chain management person, now a 3D bioprinter. Can you tell us a little bit more about what's your motivations to kind of switch? And then also, is there any specific advice to other people who are looking to kind of enter into their careers, and also looking at maybe switching careers as well?
Okay, so any advice for those thinking of switching careers? Do it. Do it. Take the jump. Because once you jump, you don't know how you're going to land, but I promise you it's worth it. Obviously, you have to be realistic. So the reason I went for the career change was because it wasn't rewarding or satisfying my personal values anymore. So I was working in big corporates, and I could see that, yep, the scale of business I was managing was interesting and it was satisfying, but the end outcome was like, if at my deathbed someone asks, so what did you achieve? So, well, I got some kiddie litter into a distribution centre. I'm sure everyone was happy. And I've always had a passion to help people. My husband's a scientist, so there's always been the passion to do science in the human body. So getting into that was, in the end, it was quite an easy decision. How I got into 3D printing in medicine was thanks to one of my fantastic lecturers at my undergrad, who I met, and she was enthusiastic about it and introduced me. And how I got into the 3D bioprinting, I saw my supervisor on TV, and it was like a light bulb moment. I thought, that's what I want to do. He was in ABC Catalyst, and I thought, I got to get onto that.
Yeah.
And I sent him an email thinking, this guy won't even have time to reply to me. He's too busy.
Yeah.
He replied the same day, come and see me.
Wow.
He's now my supervisor. So my networking tip for everyone, take the chance to contact people. If they don't reply, they don't have time, or they're the sort of person you don't want to be talking to anyway. If they do come back to you, great. Didn't cost you anything, maybe one email. Obviously, you need to know how to address these people. But yeah, career changes, I reckon I have at least one career change left in me.
Oh, really?
So, oh, yeah.
What are you going to do next?
I don't know.
Pilot?
No, we'll see. But yeah, look, you have to be realistic. I obviously had my husband who has a career, so we had financial backing. But it was at the point where our kids were young, so I needed a bit of flexibility to be at home with them if needed. Studying helped with that. Universities were fantastically supportive of young mums who had daycare and school drop-off duties. So it was the right time. But don't wait for too long. At one point, you just have to decide to jump, and it is worth it.
Nice, I like it. What about you, Louise? How did you go from academic to, and we'll keep it fairly tight.
Yeah, I think for me, I'd been at Macquarie for maybe 15 years, and a lot of research had been developed. I'd seen a lot of research developed at the university. And then you start to see that actually we need to apply this research in the real world. There's so many problems out there, and climate for me is a key driving factor. We knew that we could make it in a cleaner way. If we didn't do something with this idea, it was going to be stuck with the rest of the ideas at a university. So I feel we took a hard path by trying to spin out into a startup. But if we didn't get that IP or intellectual property out, it was just going to die with the rest of the intellectual property that sits in university commercialisation offices. So it was a drive to have impact. I think I'm like you, Niina. If I'm not adding value, I get very frustrated and bored. I think I was fortunate to have that financial security that I could step out and take a risk, and it was hard not paying myself for a couple of years and going through how is this going to work, but it was just that inherent need to add value and solve a real problem.
And you're we're at Launchpad, which is an entrepreneurship team at Western Sydney University. How did you become a founder, a female founder? Is that a hard process? Like, how did you learn from other people, or watch YouTube, or what did you do?
I was such a basic science academic. I went down the narrow path of, postdoc, lecturer, senior lecturer. Like, I had my blinders on, but I always wondered, how do people talk to industry? I didn't understand how you even approach them. And then I think I was fortunate that things changed in the last 10 years. This idea of startups came about, and the need to take some of this core IP out of universities. So back in 2017, 2018, I participated in an accelerator program, specifically targeted at academics with deep tech needing to understand how to build a business. So that was with the CSIRO, the ON program. So they have an ON Prime, which teaches you about customer discovery. In other words, get out of the building and go and talk to someone outside of your sector. And I think it gave me the skills, and it was just super interesting to meet new people. And you start to learn by doing. I've read lots of books and listened to lots of podcasts, but we've built the company by learning and making mistakes, but building that network of a lot of support.
Yeah, great. So you both talked about networking. You talked about, to go out there and just be brave and just approach people. What other skills do you think is important for your careers so far? Niina? And I'm curious about soft skills, actually, because, there are lots of hard technical skills you have, but what are some great soft skills that you think is important?
So one thing, if you change careers, do not ever overlook what you've learned from your previous career. So from there, I brought with me team leadership, operations management. So if anyone told me today, here is a lab for you, this is the budget, you run it, I can run it. And to this day, within our lab, I know I'm a good leader because a lot of my peers come to me and we work out things together. But the soft skills, I would say, they are not gender specific, they're task specific. And they're very similar across the board. But what I would like all the ladies in particular here to learn is how to say no.
Yes.
And I use a little tool for this.
Oh yeah, what's that?
I'll give you one, and I'll give you one too.
What, does it say no on there?
So these are little thank you but no thank you, saying no to things reward cards.
Oh, I love it. Look at this.
So every time I say no to something, I tick a little box, and when I get to 10 no's, I reward myself.
With a yes?
No. The reward can be anything you decide, and you have to do the reward like straight away because otherwise you forget. If anyone's interested, I have a couple of extras of this, but yes, you need to learn how to say no. And advice from my mentor was also, if you have to say no to a commitment like a speaking commitment or anything else like that, she said, try and suggest someone else to contact on your behalf. Give a contact that you know, and preferably make it a woman. So then you're saying no, but it's not a no. It's, unfortunately, I don't have time. Maybe contact this person instead. You're giving someone else the opportunity to shine.
Yeah. That's amazing. I'm going to be using this no card. Great. What about you, Louise? What soft skills do you think is important?
I don't know, but I hope you have IP protection on this because this is quite valuable. This is a great idea, and I can see an opportunity. So just be true to yourself. Don't try and be who you think you have to be. And look, I'm not a confident person in a room. I can struggle. I think we all suffer from imposter syndrome. I think that's okay.
How do you get over imposter syndrome?
I think now I just acknowledge that I have it, and that's okay, and everybody else has it. So we're all together. But it's trying to grow in confidence. It's not a soft skill that I don't know how you work on that, but it's hard. And I think the other skill that is something I think I value is I seek feedback. Just ask people, what more can I do? How did I do? How can I be better? Just be open to feedback and not take it in a negative way. If you're not getting feedback, then no one is caring. And so you need to crave that feedback, ask for it. Because if you ask for it, then you can improve and learn from it. So I just encourage you to ask for feedback.
That's very true. So let's open up to a couple of questions from the audience. Who is interested? Oh, got a hand there. Got a hand? Yes, Michelle? Well, you're going to have to call it out and we'll repeat your question.
Oh, so I try my best. So it's lovely to know the woman with science, because in the old time they said we are not the right person in the science. So however, I want to ask some challenge question, as I think it's challenging. If I can challenge you to probably give me some confidence. So as you said about the 3D printer for our organ, and you said about H2, which is, English is not my first language, but I know the chemicals, the things. So what I want to ask the more ethic on the question is, if our organ can be replaced, everything, are we still human being? That's the first question, maybe relevant to ethic, relevant to some philosophy behind. Then second question is I just think it's so easy for very simple things. Common things for the planet already exists for H2O, which is water. Why is it so difficult we take this so separate? That's the second question I want to ask. Thank you so much.
Amazing, great. Niina, are we still human when we replace our entire bodies?
Well, did you know that your body actually renews itself periodically? There are certain cell types that don't, but for example, your skin and everything, there's new cells that come out all the time. So we go through like versions of our body in that sense. For the 3D bioprinting organs, that's an excellent question. There's a lot of ethical consideration. But what we need to do for the biomaterial we use, that has to come from the native host, so from the patient themselves. So whatever we're building, we're using that person's own stem cells. Otherwise, there's rejection. Like if you had an organ from a donor, it might be rejected by the host. So if we create a new organ using the patient's stem cells, it's from their own origin. So when it's transplanted back to the same patient, the body's going to go, hey, I know you cells. You're actually me. Welcome. But if it was from another donor, they go, hang on a minute, you guys don't belong here. We're going to fight against you. Does that answer your question?
Yeah.
Okay, we get
very complex.
It's a complex, yeah.
It's extremely complex, but what I would like to say, replacing whole organs, we're so far away.
Yeah.
And for debunking the myths, if you ever see the pictures with organs in vessels in laboratory, the whole brain or heart, whatever, just being grown in the lab, burn them. Kill all those pictures. I hate them with passion because they give you an idea that this is today and reality.
Yeah.
And we're so far away from that.
So far away. Thank you. Louise?
Yeah, I'll just be brief about, we can split water to make hydrogen, but it gets down to the market of who can do it cheaper. So at the moment, the fossil fuel industry does it a lot cheaper. They use methane to get the hydrogen, and then all the CO2 and greenhouse gases go up into the sky. So they treat the sky as a sewer. So until we have carbon pricing, clean ways of making hydrogen from electrolysis, it's going to be a lot more expensive. So it's purely a unit economics challenge that is out there. Yes, we can do it more cleanly, but can we do it cheaper than the fossil fuel industry? Because that's the only way that we're going to transition across. So we need sticks and carrots to move it across. We need policy, but we can't keep treating the sky as a sewer and contaminating it. So until we stop doing that, it's going to be very challenging to adopt some of these clean technologies.
Great. For me, it was everything new. With the AI part, when it is coming up in the last couple of years, do you think that is going to help you to achieve what you're doing? And how fast it might change in a couple of years? Thank you.
Yeah, fantastic question. AI is like the hottest topic, and it's for all industries. I think it's changed a lot. What about for you, Louise?
Oh, absolutely. I think everybody needs to embrace AI, because if you don't, you might be unemployable. Yes. So we can't fight it. We have to work with it, but it can add value in so many different ways. So in our company, I mean, it depends. We collect data. We work with big data sets. It now allows us to model things a lot faster and quicker to get to the next step. But yeah, it's powerful. We can just do things a lot quicker and cheaper. So please embrace AI. It is not scary. I've got an engineer on our team that I keep saying, if you don't start working with it, you know, there's another engineer that will. So you do need to incorporate it into your career.
Niina, what about AI and bioprinting?
It's definitely, and I think it's already greatly in use with modelling things like organs and their function, the physiology. For example, with heart, a lot of that work is done using AI models. So simulating, for example, blood flow. So I think with the AI, we're going to get much more accurate presentations of different organs. And this is super, super, super important, because what we get from medical images today, we can see, there's certain tissue types and there are certain differences and changes in tissue, but how those relate together, that is really difficult. And if we can get specific models with something like AI that can tell how the cells interact together, it's going to help a lot, because printing or even making an organ in laboratory in any way, you're going to look at several different tissue types that need to come together, and they all need to talk to each other at the same time, working in the same way, running in the right direction. Our little brains, with hand-drawn things, not going to work. So we're going to need to automate a lot of that process. And it's already been done in certain areas. So yeah, definitely going to help.
Fantastic. All right. Well, final question very quickly. Main takeaways. What is your main takeaway of your career so far? And maybe just one tip that you'd like to provide to the audience. One tip. Maybe yours is say no. This is a good one.
No, my tip's actually say yes. Say yes to the change. So when it comes and you feel the pull, don't be afraid. Say yes.
Say yes. Like it. Say no and say yes.
Yeah.
No. Louise?
I don't know. I think to me, it's just listen to that inner voice of, if you know something is, you have to do it to make change, just make it happen. Just get out and do it. Don't overthink it sometimes. I think as women, we overthink things too much. And we have to make sure everybody is all sorted before we make a decision. And let's just be brave and give it a go.
Great.
Failure is good.
Oh yeah,
fail early, fail often.
I love it. Thank you so much, Niina and Louise.
What do you think about Niina and Louise's tips about saying yes to change and listening to your inner voice? I fully agree that failing fast and failing often is a great attribute to keep learning and improving yourself. Failures are not setbacks, but rather stepping stones to success. Each time we try something new and it doesn't work out as planned, we gain valuable insights that can help us refine our approach, and we become better versions of ourselves. My favorite advice is not to be afraid of change and to try new things. Often we're afraid of change, but a bit of disruption can lead to bigger and better things in our lives. The ability to adapt to change is a crucial skill in today's fast-paced, ever-changing landscape, especially to keep up with the latest emerging technologies. By embracing change and trying new things, we develop the resilience and flexibility needed to navigate the challenges that may come our way. This is not only to make us more valuable in the workplace, but also helps us become more well-rounded individuals in our personal lives as well. What are your favorite takeaways or advice for unlocking new opportunities or for continuous improvement? I'd love to hear about it in the comment section. For more information about the latest episodes, to learn more about each technology, and how you can contact us for sponsorship, promotion, or guest speaking collaborations, visit our website, emergingtechunpacked.com. Be sure to subscribe, like, and follow us on our social media channels to stay updated with the latest news. You can find me on LinkedIn searching for Lucy Lin. We welcome all feedback and will be very grateful if you can help us grow and spread the word by forwarding this episode to a friend and giving us a 5-star review. Thanks for your attention. I hope I've unpacked 3D bioprinting and green hydrogen for you to gain a better overall understanding of this incredible new and emerging technology. See you in the next Emerging Tech Unpacked episode soon.